Organic chemical reactions come in a variety of types, including substitution, where we unplug a hydrogen and plug something else in its place. Here, methane, which contains 4 hydrogens, is attacked by chlorine, which we normally write Cl2. What happens is one of the chlorines substitutes. If we try a similar reaction with ethane, there are 6 hydrogens. One, and only one, of the hydrogens pairs up with a bromine, and we get methylethane plus hydrogen bromide. You can work on rings as well. Here's cyclopropane. Let's attack it with water, but I'll write it in this interesting way, HOH. Now, in this case, if we have 2 hydrogens pair up, it leaves an OH on the ring, which turns it into an alcohol, cyclopropanol plus hydrogen. That's substitution. Now, another way to have a reaction is to add something to a double bond. Here, in ethene, there's a double bond, 2 connections. Hydrogen fluoride has a single connection. If we take the bond between HF and one of the bonds between carbon and break them up, we can rearrange the electrons in a different way. One connects from the carbon to the hydrogen that was in HF, and the other to the fluorine. This is fluoroethane. We could do the same with propene, again with water. We think of one of the bonds from the double bond coming down and grabbing hydrogen. The other bond from H and OH going to connect with the carbon. Now, the water can attack on either end of the double bond, and so we can get both 2 propanol and 1 propanol. Those extra H's aren't needed, so I'll take them out. It's about a 50-50 shot. Well, I want you to notice here that even 2 ethene molecules can combine into cyclobutane. Moving on to ester formation. When you have an organic acid, such as this one here, and it's combined with an alcohol, written here ethanol, it happens that you can see between the 2 of them a water molecule. Imagine unplugging the water molecules and plugging the remaining bits together. That makes an ester. Very similarly, an amide is formed, once again, from an organic acid, and not an alcohol this time, but instead an amine. Once again, find the water molecule that can form by unplugging a hydrogen and an OH. They become water, and the 2 other parts simply connect together to form this compound, an amide. An organic acid and an amine make an amide. The last one that we'll look at is polymerization, when a small molecule, or monomer, mono means one, mer means molecule. Here is ethene, 4 times over, but really we mean many times. In a polymerization, they combine together. Something causes one of the double bonds to attack a neighboring molecule, and you get a string of carbons, polyethylene sandwich wrap, formerly polyethene. So here's another go. This is propene, and many propene molecules can be stimulated to attack each other. Instead of a double bond, no bond, double bond, no bond, it breaks up and forms a link in a chain reaction. This is polypropylene, or polypro, a fabric used in sportswear because it sheds water and dries easily. Well, let's look at just one more to finish this up. Tetrafluoroethene, or tetrafluoroethylene. They can also be stimulated to attack each other. All the double bonds disappear, and a new bond forms between the molecules. Single bonds. Above and below we have fluorine. This is tetrafluoroethylene. Well, for trade purposes, we take the letters T, E, F, L, O, and N, and we get Teflon, the plastic with the slipperiest surface known of all plastics. Well, that's it. Let's review. Substitution, where we exchange a hydrogen. Addition to a double bond, where we add a molecule to it. Ester and amide formation. By removing a water molecule, we unite 2 larger ones. And finally, we have polymerization, where small molecules link together many times over. That's it.